Record. Okay, so last day of withdrawal today, this or any other class, and then Adfinity homework is due Friday. So today we're going to do some examples from related rates problems, and then you'll be good to do all of your homework problems. Friday, I'll answer any homework questions you have. I'll be in the AEC today after class, but I can't be there Friday after class. So today I'll be in the AEC until 3, but I can't be there Friday after class. My kids' fundraiser is finishing and I'm the PTA president, so I have to be there to do that. So today I'll be there till 3. I'll be in class Friday, but I just won't be in the AEC after class. Okay, so here's our first example. I guess it's our second example because we did one on Monday, right? Okay, a police car approaching a right-angled intersection from the north is chasing a speeding car that has turned the corner and is now moving east. So on this picture, I'm going to draw some arrows because the police car is going towards the intersection in that direction, and the speeding car is going away from the intersection in that direction. Okay, so if I was going to label this, I would call like the car X and the police Y, only because they're on the X-axis and the Y-axis. What can you tell me about the distance X? Is it getting bigger or smaller? X is getting bigger because he's moving away from the intersection. Yeah. What can you tell me about the distance Y? Is it getting bigger or smaller? Smaller because the police car is moving toward the intersection. So when I find the rate dx dt and the rate dy dt, what kind of number, positive or negative, should dx dt be? Positive, because this x distance is increasing. What kind of number, positive or negative, should dy dt be? Negative, because this distance y is decreasing. Okay, so keep that in mind when you're writing down your quantities, because we're following those steps. Draw a picture, check, label your known and unknown quantities. When you're writing down those quantities, if it's getting bigger, the rate should be a positive number. If it's getting smaller, the rate should be a negative number. Okay, when the police car is 0.6 miles north of the intersection and the car is 0.8 miles to the east, the police determine with a radar gun that the distance between them and the car, oh man, okay, let's label this guy D. The distance between them and the car is increasing at a rate of 20 miles per hour. If the police car is moving 60 miles per hour, what is the speed of the speeding car? Yeah, it looks like we're trying to find dx dt. That's my question mark. And what kind of number should it be? Positive. Positive, great. Okay, so let's see. What is dy dt? So close. Negative 60 miles per hour, because dy dt was the police car. He's going, his distance is getting smaller, so it's a negative number towards the intersection at 60 miles per hour. And how about dd dt? Is 20 miles per hour. Positive, because they tell us this is increasing right there, yeah? Okay. Okay, when these numbers, y is 0.6 and x is 0.8. So 1, draw a picture. 2, label known and unknown quantities. 3, do you remember what step 3 was from Monday? Find an equation using those variables, right? So find an equation using those variables. Let's use the Pythagorean theorem. This is a triangle. We're caring about distances. Different from the activity on Monday when we cared about an angle sometimes, right? Like in this one, they're caring about 3 distances. Let's use the Pythagorean theorem. Pythagorean theorem says x squared plus y squared is d squared. Square of the sides is equal to the square of the hypotenuse. Step 4. I'm sorry, I wrote 3 twice. I'm on 4. Find the derivative with respect to what variable? T. So I'm going to do implicit differentiation, right? And anytime I take the derivative of a variable, whether it be x, y, or d in this case, I'm going to put a dx dt, a dy dt, and a dd dt in there. Okay, so derivative of x squared. 2x dx dt, great. 2x dx dt plus 2y dy dt equals 2d dd dt. Okay, let's see what I know. I know that dy dt is negative 60, so that goes there. I know that dd dt is 20, that goes there. I know that y is 0.6, that goes there. I know that x is 0.8, that goes there. This dx dt is the thing I'm looking to find. Uh-oh, I need to know d. Yeah, let's plug in, right? I know that x is 0.8 and y is 0.6, right? If I know that, then I could use that to find out what d is going to be. So I'm going to go like take a detour for a second and say d squared is 0.8 squared plus 0.6 squared. D is, someone get your calculator. 1, is that what you said? Yes, 1. Great. No, you changed your mind? Oh, you're keeping it. 1. Good. Okay, so we found that D is 1. So now he's going to go in. What color didn't I use yet? Green. 1 is going to go right there. All right, let's plug it in. What kind of number are we looking to get out? Do you remember? Dx dt should be a positive number, right? Because x was the car is moving away from the intersection. The distance is getting bigger. I should get a positive number out. Okay, 2 times 0.8 dx dt plus 2 times 0.6 times negative 60 is 2 times 1 times 20. Okay, 2 times 1.8 or 0.8 is 1.6 dx dt minus, what's that? 36 times 2, 72 is 40. Someone check that number, it might be wrong. 1.6 dx dt, add, is it 72? Yeah. Great. Add 72 to both sides, 112. Divide by 1.6. Dx dt is 112 divided by 1.6. 70. 70. Dx dt is 70. So I just divided both sides by 1.6. Yes, sir.
So I had a question. I kind of forgot what you said about it. How do we know what goes on top and what goes on bottom for like dx over dt? How do we know it's
The dt always goes on top, always goes on bottom. The thing on top is the variable that you're taking the derivative of. Yes.
I did figure out 0.8 and 0.6 for those given.
They were given to me. Yep. Right here it says when the police car is 0.6 miles north and the speeding car is 0.8 miles to the east. Yeah, so they were given to me. Yeah, step 5 is you started with words. You should have words in your answer. Miles per hour, because this is dx is the miles, the distance, and time is an hour. So miles per hour. So the speeding car is moving away from the intersection at a rate of 70 miles per hour. So 1, draw a picture. If it's there already, great. 2, write down your knowns and unknowns. Remember, you can't plug in your values unless they never change, right? On the activity we did on Monday, like when you had a 15-foot ladder, that never changes. So you could put in 15 for the ladder because it never changes. If a quantity changes, you got to give it a letter and it's got to stay that letter the whole time. Step 3, make an equation. Step 4, derivative implicitly with respect to watt t, and then plug in and solve. That's probably step 5, I think. Like right here, 5. I don't know. I don't remember. Okay, let's try again. A rocket lifts off at the Kennedy Space Center in Florida. A camera is placed 2,000 feet away from the launch pad to film the rocket's ascent.
That camera is
2,000 feet is not nearly enough. The height of the rocket can be found using this function. S of t is 50t squared, where s is feet and t is seconds. Find the rate of change in the angle of elevation of the camera at 10 seconds after liftoff. Really? Okay, 2,000, like that's almost half a mile away, right? That's
with
too
the
close
amount
to a
of
rocket.
propulsion in a rocket, it's the smoke and the heat that billows out.
It's just gonna get the camera. Fine. Okay, 20,000.
Height of the rocket.
Okay, here's my rocket.
How tall the rocket is or how?
The
far away
height
from
means
base?
how it's moving up.
Okay.
Yeah, it's height from the ground.
We're talking about raising at
Find the rate of change in the angle of elevation of the camera at 10 seconds. Yes. Okay, so the rocket's going up in the air. There's a camera over here. I know, that's my rocket. It's the best you're gonna get. That's a better camera than a rocket. No, it's not a good camera. Oh, I need it because they have to see out, right? Yeah. That's gonna help, I think. Now it looks like the dudes from the, what's that game? What is that? Yeah, Among Us. Yeah, my kids played that a lot. Now it looks like the dude from Among Us with 3 legs. Okay, so the rocket's going up in the air. The camera is looking at the rocket. There's an angle here, theta. Yes, this guy H is going up in the air. Is this 2,000 changing? 2,000 never changes, right? So I can use 2,000 at the very beginning. The camera's not going in and out. It's just rotating like this. That's all it's doing. But H is changing, the height of the rocket is changing, and the angle is changing. Number 1, draw a picture. Number 2, what's step 2? Write down what you know and what you need to find, right? Okay, so what are we trying to find? The change, the rate of change to the angle of elevation. So we're trying to find d theta dt. That's my question. We're trying to find d theta dt. Okay. Oh, they called this S instead of H. They didn't call it H, they called it S. Okay, so the height is 50 t squared. Can you find the derivative of the height? Well, I mean, we're gonna have to have dh dt, I imagine, don't you? I don't know, maybe not, but I think so. 100 t, yeah. Okay, when t equals 10 seconds, because the 10 seconds was right there. Okay, so here's what I got. I've got an angle. I've got this side H, and I've got this side 2,000. So I've got an angle. I've got this side H and this side 2,000. Can you make an equation? Let's use, I would just use tangent, right? Tangent, I have an angle, I have the opposite, and I have the adjacent. So tangent of theta is equal to H over 2,000. Okay, step 4 says take the derivative with respect to t. Okay, derivative of tangent? Secant squared theta times times
100t.
d theta dt equals close.
Oh, 0.
You want to use the quotient rule? Really?
Yeah.
I don't want to. When the denominator is just a constant, right? This is like 1/2000 times h. Yeah? What's 1/2000 times h? What's the derivative of 1/2000 times h? Yeah, just 1/2000 times dh dt, yeah, which is going to be 100t, right? Okay, so now we have to do a little bit of work because I don't know all these quantities, right? Like, here's my list of stuff I know. I know that the height is 50t squared. I know that the derivative of the height is 100t. I know that t is 10. I have to use all that stuff to find out what's dh dt when t is 10. What is the theta when t is 10, right? Or what is secant of theta when t is 10? So I'm going to have to use that stuff to figure out what happens when t is 10. So over here, I'm going to draw a new triangle. And I'm going to draw the very specific triangle. That's a bad triangle. I'm going to draw a new triangle. Better. When t is 10. Okay, so here's my theta. What's this bottom of the triangle? Yeah, still 2000. Can you tell me this distance if t is 10? Plug in 10 for t, right? So 10 squared times 50 makes 5,000. Can you tell me the hypotenuse when t is 10? Pythagorean theorem, yeah. So 2,000 squared plus 5,000 squared, take the square root. I think we need that information because I need the secant. Yeah, like I don't want to find out what this angle is because that's annoying. If I know the third side, then I can find the secant and just square it by using the three sides. I think that's easier than finding the angle.
So how do you 5,000?
I got the 5,000 because this is the height, and when t is 10, I just plugged in 10 for t to the height equation. I'm ready.
That's like decimal.
Just give me like the whole number.
5,385.16.
Okay, so I found the pink triangle using the stuff I knew with t equal to 10 seconds, because that's the moment I care about, right? So I found the pink triangle using the stuff I knew with t equal to 10 seconds. What about dh dt? How do I find dh dt when t is 10? You plug it into h prime, right? So dh dt when t is 10 is 100 times 10, 1,000. Positive or negative? Positive. This rocket's going up. The height is getting bigger, right? Positive. What do you expect about d theta dt? Positive or negative? Yeah, the angle's getting bigger, right? It's looking up at the rocket, the angle's getting bigger. We expect that d theta dt is going to be positive as well. Okay, let's plug in what we know now. 5. Secant is hypotenuse over adjacent. So hypotenuse over adjacent squared d theta dt is 1/2000 times dh dt, which I found here, 1,000. Okay, solve for me d theta dt. The answer is 1/1000. You got to do like this. This would be 1/2. This side is going to be 1/2, and then you got to like 1/2 divided by that thing. Yeah. Just do the whole thing. uh, 5385.16 over 2000 squared.
1,000 back and you did GH or DG.
I plugged 10 into the H prime equation. Because DHGT means the derivative of H. And they told me that T equals 10. That was the time I was caring about. So I plugged 10 into the derivative equation. I got 0.07. Anybody else? Great. 0.07.
Why this is, oh wait, never mind.
Yeah, why is it so small? What is it measuring?
Level of elevation.
Yeah, how fast the angle is changing, right? How fast the angle is changing. So it's changing 0.07 angles, like radians, per, what was T?
10 seconds.
Seconds, yeah. So 0.07 radians per second. So 0.07 radians per second. Okay, let's see if I can fit it all on at one time. Oh dear Lord.
Second to look at this problem.
Yeah.
Secant is hypotenuse over adjacent.
Yes. I think. I'm confident. Secant is whatever cosine is hypotenuse adjacent over. Yes.
So good, so.
Oh, yeah, right, we got it. Okay, everybody's ready? Yes. Great. All right, let's do the cone. Water runs into a conical tank at the rate of 9 feet cubed per minute. What does the amount of water in a tank represent about it? The volume. Okay, good. Okay, great. The tank stands point down and has a height of 10 feet and a base of 5 feet. So that's the whole tank, right? The whole tank's not full of water though. Yeah. The whole tank is 10 feet high and a radius of 5 feet. How fast is the water level rising? So that's how fast is this distance, like here's the water. How fast is the water level going up? When the water is 6 feet deep, the volume of a cone is here. Oh, that was nice of us. How fast is the water level rising? Okay, I have a picture. Great. Okay, in this picture, I'm going to label 10 and 5. Okay, in this picture, I'm labeling 10 and 5. That's the whole cone, though. That's not just the water part of the cone. The water part of the cone is down here. Let's do light blue water. The water part of the cone is down here, right? This is all filled with water down here. What I want you to notice, though, is that the water part of the cone and the big cone make 2 triangles which are similar. Do you see that? The water part of the cone and the big cone tank make 2 triangles which are similar. There's this water cone here, which has a height and radius that we don't know at all. And then there's the big cone here, which has a height of 10 and a radius of 5. Yes, and these 2 triangles are similar. Do you know anything about similar triangles? Somebody does. Yeah, they have to have the same angles, and we agree that the bottom angle of the blue triangle is the same as the bottom angle of the black triangle because they're the bottom of the cone, right?
Yeah.
And this angle in the top left corner is a 90-degree angle in both. So these these triangles are similar because their angles are the same. What do you know about the sides of a similar triangle? Yeah, they're ratios. They're in proportion, right? Their ratios are the same. You can set up a whole bunch of equations, right? You can say R over H is equal to 5 over 10. If you want to, you can say R over 5 is equal to H over 10, right? You can set up a whole bunch of different ratios as long as whatever you put on top of the other one goes, whatever you put on top of one goes, the similar part goes on top of the other, okay? So that's going to give us a whole bunch of ratios. That's going to be important later. Okay, step number 1, draw a picture. Step number 2, what's step number 2? Write down what you know and what you're trying to find. Okay, I highlighted in green what we're trying to find. How fast is the water level rising? So what am I trying to find? How fast is the water level? DH, the height of the water, dt. So I'm trying to find DH dt. Okay, what do you know? What is the 9 feet cubed per minute? That's the volume. dV dt, perfect, is 9. Look at this. H, yep, is 6. Yeah, the water is 6 feet deep, so H, the height of the blue triangle, is 6. Okay. Step number 3. What's the matter?
Like, you know, I play selfie get it. But it's too late.
You know, I posted on D2L afterwards, right?
Yeah, but I like.
You like it in the
progression,
middle.
like progression.
I see. Okay. You want to go? Yeah, go take some. You do it. I won't get in the way. In my other class, I have this upper level math class. And they do board work and then I take pictures. And there's one student who likes to like Vanna White it when she gets her picture taken. She's like, this is my work today. Okay, what's step number 3? Now that Matthew's distracted. We need an equation, right? Okay. Do we have an equation? Yeah. Miguel says we should use what? The volume of the cone. It's up there, right? V equals 1/3 pi r squared h. The problem with this equation is that our information over here is only about v and h, right? So this equation that we found would be a lot better if r wasn't there. What didn't we use yet? The similar triangle part. Can you use the similar triangle part to get rid of r?
Yeah.
Sure. I didn't say yes, I just told you you could. Right? Yes, let's use the similar triangle part to get rid of r. Okay, so I'm going to detour over here to the similar triangles. So here we go. I'm going to set it up as r over 5 is equal to h over 10. So I did the radius over the radius of the whole cone is the height over the height of the whole cone. R over 5 is equal to h over 10. Can you solve for r? Yes. How? Cross multiply. Okay. Or just multiply both sides by 5 would be easier, right? And we get 5h over 10, the same as h over 2. Okay. So in here, I'm going to use the similar triangles and replace r with h over 2. Volume is 1/3 pi times h over 2 squared times h. And before I take the derivative, I'm going to do some simplifying because if I don't have to, I don't want to use the product rule, right? Like if I can avoid it, I'm going to try to avoid the product rule.
So it's 1/6.
Close. H over 2 squared is h squared over 4. Yeah, 1/3 times 1/4 makes 1/12. And then h squared here times h makes h cubed. So this is 1/12 pi h cubed. 1/12 pi h cubed. So h over 2 squared was h squared over 4. I multiplied the denominators, 3 times 4 makes 12. And then h squared and h makes h cubed. Okay. I do a lot of setup in that one, right? But now the rest should be easy. I shouldn't have to do any more setup or work or anything. I should just be able to do some stuff and plug it in. What's step 4? Derivative with respect to t. dv dt is, how do I take the derivative of this guy? Yeah, 1/12 pi times 3h squared dh dt. Okay, I am looking for dh dt. What kind of number, positive or negative, should dh dt be? Positive, because they're adding water to this tank, right? So the height of the water should be going up. You're going to see some problems where they're draining water or sand out of the bottom of the tank. And then the height should be going down, right? So pay careful attention to whether the amount is getting bigger or the amount is getting smaller. Okay, let's plug in all the stuff I know. I know that dv dt is 9. I know that h is 6. I'm looking for dh dt. So I'm going to plug in all those numbers. 9 is 1/12 pi, 3 times 6 squared dh dt. 9 is, let's see, 6 squared is 36. 48 pi. Is that wrong? That's wrong. 12 pi? 3 times 6 squared divided by 12. What do you get when you do 3 times 6 squared divided by 12? 4, 9. Yeah?
Yeah.
Okay, I'm trying to solve for dh dt. Divide by what? 9 pi. So I get 1/pi, which is about some number. 0.32. Okay, I'm going to scroll up just for a second, but I promise I'm coming back down, right? Because what do I need to add? Units, right? So the height is in what kind of units? Feet, and the time is in minutes. So these units should be feet per minute. Right? These aren't even the hard ones.
Huh.